What's up, friends? This week on the Changelog, we're talking with Georgy Gerganov about his work on Whisper.cpp and LLaMA.cpp. You're gonna love it. He first crossed our radar with Whisper.cpp, which is his port of OpenAI's Whisper model in C and C++. Whisper is a speech recognition model enabling audio transcription and translation, something we're paying very close attention to here at Changelog. Between the invite and the show's recording, Georgy had another hit project on his hands, LLaMA.cpp. This is a port of Facebook's LLaMA model in C and C++. Whisper CPP made a splash, but LLaMA.cpp is growing in GitHub stars faster than Stable Diffusion did, which was a rocket ship in and of itself. A massive thank you to our friends and our partners at Fastly and Fly. Our pods are fast to download globally because Fastly, they are fast globally. Check them out at fastly.com. And our friends at Fly let you put your app in your database close to your users all over the world with no ops. Learn more at fly.io. This episode is brought to you by our friends at Postman. Postman helps more than 25 million developers to build, test, debug, document, monitor, and publish their APIs. And I'm here with Ken Lane, Chief Evangelist at Postman. So Ken, I know you're aware of this, but companies are becoming more and more aware of this idea of API-first development. But what does it mean to be API-first to you?
API-first is simply prioritizing application programming interfaces, or APIs, over the applications they're used in. APIs are everywhere. They're behind every website we use, every mobile application, every device we have connected to the internet, our cars. And what you're doing by being API first is you are prioritizing those APIs before whatever the application is that is putting them to work. And you have a strategy for how you are delivering those APIs. So you have a consistent experience across all of your applications.
Take us beyond theory. Break it down for me. What changes for a team when they shift their strategy, when they shift their thinking to API first development?
So when your one team goes, hey, we're building a website, it's got a address verification and part of an e-commerce solution, that web application is using the APIs to do what it does. And then when another team comes along and goes, hey, we're building a mobile application that's going to do a similar e-commerce experience and may use some of the similar API patterns behind their application. They need address verification. That's a consistent experience. Those two teams are talking rather than building in isolation, doing their own thing and reinventing the wheel. And then when a third team comes along, needs to build a marketing landing page that has address verification, they don't have to do that work because those teams have already collaborated, coordinated, and address verification is a first-class part of the experience, and it's consistent no matter where you encounter that solution across the enterprise. And that can apply to any experience, not just address verification.
Very cool. Thank you, Ken. Okay, the next step is to go to postman.com/changelogpod. Again, postman.com/changelogpod. Sign up and start using Postman for free today. Or for our listeners already using Postman, check out the entire API platform that Postman has to offer. Again, postman.com/changelogpod.
Well, exciting times to say the least. Welcome to the show, Georgy.
Nice to have me here. Thank you for the invite.
You bet, and happy to have you on your first podcast. So we're having a first here.
Yeah, I'm a bit excited.
We're excited too. I wasn't sure you were going to say yes. You're a very busy guy. You have, well, at the time that I contacted you, you had one project that was blowing up. Now, since then, you have a second project that is blowing up even faster, it seems. The first one, Whisper.cpp, which we took an interest in for a couple of reasons. And now LLaMA.cpp, which is like brand new this week, hacked together in an evening, and is currently growing on GitHub stars, according to the thing you posted on Twitter, at a faster rate than Stable Diffusion itself. So, man, what's with all the excitement?
Yeah, that's a good question. I still don't have a good answer for it. But yeah, I guess this is all the hype these days. People find this field to be very interesting, very useful, and somehow with these projects and with this approach that I'm having, like coding this stuff in C and C++, running it on the CPU, it's kind of generating additional interest in this area. And yeah, so far it feels great. I'm excited how it evolves.
Yeah, it's pretty cool. I think that these large language models and AI has very much been in the hands of big tech and funded, organizations, large corporations, and some has been open source, and we started to see it kind of trickle down into the hands of regular developers. And OpenAI, of course, leading the way in many ways. They have their Whisper speech recognition model, which allows for transcription, allows for translation. And your project, Whisper.cpp, which is a port of that in C and C++, was really kind of an opportunity for a bunch of people to like take it and get our own hands on it, and run it on our own machines and say, okay, all of a sudden, because this model itself has been released, I don't need to like use an API. I can run it on my MacBook. I can run it on my iPhone. I can run it on, the new ones are getting run on Pixels. It's getting run on Raspberry Pis, etc. And that's exciting. So I was just curious, when you started Whisper.cpp, why did you decide to code that up? What was your motivation for starting that project?
Yeah, I'll be happy to tell about a little bit the story about how it came together. But as you mentioned, yes, like the big corporations, like they're producing and holding most of the interesting models currently.
Right.
And being able to run them on consumer hardware is something that sounds definitely interesting. Okay, so Whisper CPP, it was kind of a little bit of luck and good timing. Actually, most of the stuff has been this way. And how it started. So Whisper was released in the end of September last year. And by that time, I was basically a non-believer, like non-AI believer. I didn't really believe in this. I didn't really believe in much in the neural network stuff. And like, I don't know, like more conservative point of view, like I was wondering usually like why are these people wasting so much efforts on this stuff? Mm-hmm. But I mean, totally ignorant point of view. I wasn't really familiar with the details and stuff like this. But when Whisper came out, I happened to be working on a small library. It was like a kind of a hobby project. Basically, this is the GGML library, which is at the core of Whisper CPP. And it's like a very tiny project implementing some tensor algebra. I was doing this like for some machine learning tasks, like work-related stuff also. But I usually hack quite a lot of projects in my like free time, like side projects, like try to find some cool and interesting ideas and stuff like this. And usually I do this in C++, but I was looking to like change it a little bit. And so GGML was an attempt to write something in C, like real men do. And
for sure.
Yeah. So I was working on this library. I wanted to have like some basic functionality, like make it kind of efficient, like very strict with the memory management, like avoid unnecessary memory allocation, have multi-threading support, like be some kind of a tool that you can basically use in other projects to solve different machine learning tasks. And yeah, I mean, I wasn't thinking about neural networks at all. Like, as I mentioned, it was kind of not interesting to me at that point. And Okay, so I had some initial version of GGML, and there was some hype about GPT by that time, I guess, and also I was definitely inspired by Fabrice Ballard. Like he has a similar tensor library, LibNC, I think it's called, and there was an interesting idea to try to implement a transformer model like GPT-2 is such a model. And I already had the tools, like had the necessary functionality. So I gave it a try. I actually found some interesting kind of a blog post or tutorial, like GPT illustrated or something like this, GPT-2. I went through the steps. I implemented this with GGML. I was happy. It was running. It was generating some junk, like random texts. And I posted on Reddit, maybe also Hacker News, I forgot. But basically no interest. And I said, okay, I guess that's not very, very interesting to people. Let's move on with other stuff. Like the next day or like the day after that, I don't know, Whisper came out and I opened the repo of OpenAI, the Python repo. I look at the code and I figured basically this 90%, I have the code already written for the GPT-2 because the transformer model in Whisper, it's kind of very similar to GPT-2. I mean, there are obviously quite some differences as well, but the core stuff is quite similar. So I figured, okay, I can easily port this. It might be interesting to have it running on a CPU. I know that everybody's running on the GPUs, so probably it will not be efficient. It will be not very useful, but let's give it a try. And that's basically how it came. And yeah, it slowly started getting some traction.
Mm-hmm. So Whisper was interesting to me immediately for a couple of reasons. First of all, we obviously have audio that needs transcribed, and we always are trying to improve the way that we do everything. And so automated transcriptions are very much becoming a thing. More and more people are doing them. And so that first of all, I was like, okay, a Whisper implementation that's pretty straightforward to use, on our own. Obviously you call it a hobby project. Do not use it for your production things. Do not trust it, but it's proven to be pretty trustworthy. And then the second thing that was really cool about it was just how simple it was insofar as the entire implementation of the model is contained in 2 source files, right? So you have it broken up into the tensor operations and the transformer inference. One's in C, the other's in C++. And that's just as a person who doesn't write C and C++ and doesn't understand a lot of this stuff, it still makes it approachable to me where it's like, okay, this isn't quite as scary. And for people who do know C and C++, but maybe not know all of the modeling side and everything else involved there, very approachable. So A, you can run it on your own stuff, CPU based. B, you can actually understand what's going on here, if you give these 2 files a read, or at least high level. And so I think that was 2 things about Whisper that were attractive to me. Do you think that's what got people the most interested in it? The other thing is it was very much pro Apple Silicon, pro M1, and a lot of the tooling for these things tend to be not Mac first, I guess. And so having one that's actually it's going to run great on a Mac because of all the new Apple Silicon stuff, I guess that was also somewhat attractive.
Yeah. So yeah, what made it attractive, I guess, as you said, okay, the simplicity, I think definitely it's about 10,000 lines of code. It's not that much, but overall, these neural networks that set the core there, they're actually pretty simple. It's simple matrix operations, additions, multiplications, and stuff like this. So it's not that surprising. Yeah, another thing that generated interest was the speed, and it's a bit tricky topic. But yes, so I was mostly focused on learning this on Apple, and so I'm I don't use Python a lot, and pretty much I don't use it at all, and I don't really know the ecosystem very well. But what I figured is you basically, if you try to run the Python code base on M1, it's not really utilizing yet the available resources of these powerful machines yet, because if I understand correctly, it's kind of in the process of being implemented to be able to run these operations on the GPU or the neural engine or whatever. And again, maybe it's a good point to clarify here, like maybe there's some incorrect stuff that I will say in general about Python and transformers and stuff like this. So don't trust me on everything because I'm just kind of new to this.
Sure.
Okay, so you run it on M1. The Python, it's not really fast, and it was surprising when I run it with my port. It was quite efficient because for the very big matrix multiplications, which are like the heavy operations during the computation, I was in the encoder, like in the encoder part of the transformer. I'm running those operations with the Apple Accelerate framework, which is like an interface that somehow gives you extra processing power comparing to just running it on the CPU. So it was efficient running Whisper CPP. I think people appreciated that. There was I said it was a bit tricky because there was this thing with the text decoding mode. So yeah, I'll try not to get into super much details, but there are like basically two modes of decoding the text, like generating the transcription. They call it a greedy approach and beam search. Beam search is much heavier to process in terms of computational power compared to the greedy approach. I just had the greedy approach implemented and it was running by default. Mm-hmm. While on the Python repo is the beam search running by default. And I tried to clarify this in the instructions. I don't think a lot of people really
notice the difference.
Yeah. And so they're comparing a little bit apples to oranges. But
oh man, good pun.
Yeah.
I'm curious what it takes to make a port. Like what exactly is a port? Can you describe that? So obviously Whisper was out from an OpenAI that was released. What exactly is a port? How did you sort of assemble the pieces to create a port?
Yeah, I think port is not super correct word, but I don't know. Usually you port some software, you can port it from some certain architecture, like, I don't know, running on a PC, and then you port it there, implement it, and it starts running on a PlayStation or whatever. Like this kind of makes more sense to call a port. Here is just maybe a re-implementation. It's more correct to say, but it basically, the idea is to implement these computational steps, and the input data, the model, the weights that were released by OpenAI, they're absolutely the same. You just load it, and instead of computing all the operations in Python, I'm computing them with C. And
right.
Yeah, that's it.
Gotcha.
You probably recall when Whisper first dropped, I did download it and run one of our episodes through it. And this was back, remember on Get With Your Friends with Matt, I was talking about my pip install hesitancy.
Yes.
Like some of that is with regards to Whisper, because like Georgi, I'm not a Python developer. And so I'm very much coming to Whisper as a guy who wants to use it to his advantage, but doesn't understand any of the tooling really, and so I'm kind of prodding at a black box and following instructions. And I got it all installed and I ran everything, and I took one of our episodes and I just kind of did their basic command line flags that they say to run with like the medium model or whatever it was, kind of like the happiest path. And I ran our episode through it and it did a great job. It transcribed our episode in like something like 20 hours on my Mac. And so remember at that time, Adam, we were talking about, well, we could like split it up by chapter and send it off to a bunch of different machines and put them back together again, because we're like 20 hours is, well, faster than our current human-based transcriptions, but still it's pretty slow. And I did the same thing with Georgi's Whisper.cpp when he dropped it in September or October or whenever that happened to come out. And again, just the approachability of like, okay, clone the repo, run the make command, right? And then run this very simple /main, whatever, pass it your thing.
Yeah.
And the exact same episode, it was like 4 or 5 minutes. versus 20 hours. Now, I could have been doing it wrong. I'm sure there's ways of optimizing it, but just that difference was, okay, I installed it much faster. I didn't have to have any of the Python stuff, which I'm scared of. And at least in the most basic way of using it, each tool, it was just super fast in comparison. And so that was just exciting. I'm like, oh, wow, this is actually approachable. I could understand it if I needed to. And it seems like, at least on a M1 Mac, performs a whole lot better with, we're pretty much the same results because, like Georgi said,
right,
it's the same models, right? Like, you're using their same models. You're just not using all the tooling that they wrote around those models in order to run the inference and stuff.
Mm-hmm. When you're speaking to the main directory in the examples folder for whisper.cpp, there's a README in there that sort of describes how you use the main file and pass a few options, pass a few WAV files, for example, and out comes a transcript wherever using different flags you can pass to the main.cpp C++ file essentially to do that.
Yeah. So regarding the repo and how it is structured, I kind of have an experience with. I know what people appreciate about such type of open source project, and it should be very simple. Like, every extra step that you add, it will push people. As I wanted to make something like, you clone the repo, you type make, and you get going. And yeah, that's how it currently works. And the README, there are instructions how to use it.
I guess to preface that, or to suffix that, the quick start guide, or at least the quick start section of your README, says you build the main example with make, and then you transcribe an audio file with ./main, you pass a flag of -f, and then wherever your WAV file is, there you go. It's as simple as that once you've gotten this built onto your machine.
Yeah, exactly. There are extra options. You can fine-tune some parameters of the transcription and the processing. By the way, it's not just, the main is like the main demonstration, like with the main functionality for transcribing WAV files. But there are also additionally a lot of examples. Like, that's one of the interesting things also about Whisper CPP. I tried to provide very different ways to use this model, and they're mostly just basic hacks and some ideas, like from people wanting some particular functionality, like doing some voice commands like Siri, Alexa, stuff like this. So there are a lot of examples there, and people can take a look and get ideas for projects.
This episode is brought to you by Sentry. They just launched Session Replay. It's a video-like reproduction of exactly what the user sees when using your application. And I'm here with Ryan Albrecht, Senior Software Engineer at Sentry, and one of the leads behind their emerging technologies team. So Ryan, what can you tell me about this feature?
Well, Sentry's always had a great error and issue debugging experience. We've got features like being able to see stack traces and breadcrumbs. So you got a lot of context about what the issue is. But a picture's worth 1,000 words, and a movie is probably worth 1,000 pictures. And so Session Replay is going to give you that video-like experience where you can actually click through from your issue and see how did the user get into the situation, what was the error, and then what happened afterwards.
That's pretty cool. Okay, so this pun is kind of intended, but can you paint a more visual picture for me?
So when you open a replay for an error, what you see on the screen is, on the left side, you've got a video player with a play pause button on the bottom. You can adjust the speed. And on the left side, you've got all your developer tools. The console's there, the network is there. You can dig in to see what requests were failing, what were the messages that your application was generating. And you can scrub through the video backwards and forwards to understand what happened before and after this issue, what was leading up to it, and what do you have to go and fix.
Very cool. Thank you, Ryan. So if you've been playing detective, trying to track down support tickets, read through breadcrumbs, stack traces, and the like, trying to recreate this situation of a bug or an issue that your application has, now you have a game-changing feature called Session Replay. Head to Sentry.io and log into your dashboard. It's right there in the sidebar to set up in your front end. And if you're not using Sentry, hey, what's going on? Head to Sentry.io and use the code PARTYTIME. That gets you 3 months for free on the team plan. Again, Sentry.io and use the code PARTYTIME. going one layer deeper, maybe not even necessary for everyone else, but for you and I, Jared, maybe this is more pertinent. Limited to 16-bit WAV files. Why is the limit to 16-bit? I know we often, at least I record in 32-bit. So when I'm recording this, I'm tracking this here in Audition, my WAV files are in 32-bit because that gives a lot more information. You can really do a lot in post-production with effects and stuff like that, or decreasing or increasing semblances and just different stuff in audio to kind of give you more data. And I guess in this case, you're constrained by 16-bit WAV files. Why is that?
Yeah, the constraint is actually coming from the model itself. Basically, OpenAI, when they trained it, I think they basically use this type of data format, I guess. And so you have to give to the model the input audio that you give. It has to be 16 kilohertz, right?
16-bit WAV files is in your README, so I'm going based on that.
It's probably a mistake.
Nah.
It's 16-bit PCM. Okay, it's
yes.
Integers, not floats. Yeah, okay, so it's 16-bit and it's also 16 kilohertz. But technically you can resample and convert any kind of audio, whatever, like
for sure,
sample rate to 16. And yeah, I mean, would you get better results if like the model was able to process higher sample rate or higher capacity?
It's just one less step, really, because you've got the FFmpeg in here now. You got one more dependency really in the chain of if we were leveraging, say, this on a daily basis for production flows to get transcripts or most of the way for a transcript. So that's just one more step, really. It's not really an issue necessarily. It's just more like one more thing in the tool chain.
Yeah, that's the drawbacks of C and this environment. You don't have like Python. You just pip install whatever, and you can have party libraries. Here it's more difficult, and you have to stick to like the basics.
Mm-hmm. So your examples have a lot of cool stuff. Karaoke style movie generation, which is experimental. You can tweak the time stamping and the output formats kind of to the hilt to get exactly what you're looking for. And then also you have a cool real-time audio input example where it's basically streaming the audio right off the device into the thing and, saying what you're saying while you're saying it or right after you say it. I hear the next version, it's going to actually do it before you say it, which will be groundbreaking. But what are some other cool things that people have been building? Because, I mean, the community has really kind of bubbled around this program. Do you have any examples of people using Whisper.cpp in the wild or experimentally that are cool?
Yes. Yeah, this is definitely one of the cool parts of the project. I really like the contributions and people using it and giving feedback and all this stuff. Yeah, I definitely, there are quite a few projects already running it. Like there are people making iOS applications, macOS applications. There are like companies like with bigger products integrating it into them. Not sure we should say names, but it's definitely being applied in different places. And yeah, I guess another interesting application is at some point we got it even running in a web page. And one of the examples does exactly that. Basically, with WebAssembly, you can load the model in a web page in your browser. And basically, you don't even have to install like the rep or compile it. You just open the browser and you start transcribing. You still have to load the model, which is not very small. But it's amazing it can run even in a web page. And I think there are a few services, like web services, that popped up using this idea to offer you a free transcription.
Right.
Could you, kind of obvious, but could you deploy that or distribute that through Docker, a Docker container, for example? That way you could just essentially, Docker compose up and boom, you've got, maybe a web service on your local area network if you wanted to, just to use or play with.
Yeah, I guess so. I'm not familiar with Docker environment, but I think you should be able to do it. I see like people are already using it for the LLaMA, and I guess there's no reason to not be able to. I don't know the details.
Of course, you can do it as a web service, but sometimes you want, no dependence on anybody's cloud, whether it's, literally a virtual private server that you've spun up as your service, or simply, hey, I want to, use this locally in Docker or something like that. And just essentially you've built the server in there. You've got whatever flavor of Linux you want. You've got, whisper.cpp already in there, and you've got a browser or a web server running it just to ping for a local area network. It could be, you can name the service whisper.lan, for example.
Yeah.
You could totally get that done, I think. So you brought up the fact that people are running this in the browser in WebAssembly. Opportunistically, I would like to get on the air my corollary to Atwood's Law that I posted last week on the socials. You guys know Atwood's Law? Any application that can be written in JavaScript eventually will be written in JavaScript. Well, my corollary, which I'm not going to call it Santos corollary because that would be presumptuous. I'm not going to call it that, but I don't have a name for it yet. But it is any application that can be compiled in WebAssembly and run in the browser eventually will be compiled to WebAssembly and run in the browser because it's just too much fun, right? The most recent example would be this one. But prior to that, they're running WordPress in the browser now. Not like, the rendered HTML of a WordPress site in your browser, like the back end in your front end in your browser, because WebAssembly, we just love it and we want to run everything in it.
Why would you do that?
To show everybody that you can do it.
Okay. Look, Mom.
I'm sure there's other reasons, but that
this
was pretty much what their blog post was. The folks who did it, I think it's the wasmlabs.dev folks put WordPress into the browser with WebAssembly because we can do it now. And so we're going to.
Yeah.
So that was just me being opportunistic. Back to you, Gorgie. If we talk about Whisper and the roadmap. So it's 1.2. It's been out there for a while. My guess is it's probably being less important to you now that LLaMA.cpp is out, but we'll get to LLaMA in a moment. You have a roadmap. On your roadmap is a feature that I'm interested in because I told you this when I contacted you. And this goes back to the meme that we created years ago, Adam. Remember how we said that the changelog is basically a Trojan horse where we invite people on our show and then we lob our feature requests at them when they least expect it?
Before, as I was preparing for this conversation, I was thinking, Jared's going to say this in this show for sure. I invited you here to give you my feature request.
Right. And to make it, more pressure-filled feature request.
That's right.
But I'm just mostly joking because I realize this is seems like it's super hard. And you can talk to that. But diarization, I don't know if that's how you say it. Speaker identification is the way that I think about it. Is not a thing in Whisper. It doesn't seem. It's certainly not a thing in Whisper.cpp. I've heard that Whisper models aren't even necessarily going to be good at that. There's some people who are hacking it together with some other tools where they use Whisper, then they use this other Python tool, then they use Whisper again in a pipeline to get it done. This is something that we very much desire for our transcripts because we have it already with our human transcribed transcripts. It's nice to know that I was the one talking and then Georgie answered and then Adam talked. And we have those now, but we wouldn't have them using Whisper. And it's on your roadmap. So I know it's down there. There's other things that seem more important like GPU and stuff, but can you speak to maybe the difficulties of that, how you'd go about it, and when we can have it?
This feature is super interesting from what I get from the responses. Basically being able to separate the speakers. You're right. So basically it's not out of the box supported by the model, and there are third-party tools, and they're themselves, those tools are other networks, doing some additional processing. And again, I basically have almost absolutely no idea or expertise with this kind of stuff and what works and what doesn't work, and basically zero. And there were few ideas popping around using Whisper in not traditional way to achieve some sort of diarization. And it boils down to trying to extract some of the internal results of the computation and try to classify based on some, let's say, features or I don't know. I'm not sure really how to properly explain it, but so I tried a few things. I know people are also trying to do this. I think I guess it's not working out. So
yeah,
I don't know. This law, unlikely, at least from my point of view. Maybe if someone figures it out and it really works, we could probably have it someday. But for now, it seems unlikely.
It's a pipe dream.
I don't understand why it's a pipe dream. It seems because there's other transcription services out there that have it, that are not, LLM based or AI based. They're just, I don't know how they work, honestly. But for example, I had Connor Sears from Rewatch on Founders Talk a while back. And one of the killer features I thought for Rewatch, so just a quick summary, Rewatch is a place where, teams can essentially upload their videos to Rewatch later. So you might do an all hands demo, you might do a Friday demo of like your sprint or whatever, and new hires can come on and rewatch those things or things around the team and whatnot to sort of catch up. It's a way that teams are using these videos and also the searchable transcripts to provide an on-ramp for new hires and or training or just whomever, whatever. That's how they're using them. He actually came from GitHub, and they had this thing called GitHub TV when he worked there. And Connor's a designer. And long story short, they've had this thing. And so he really wanted the transcription feature. And they have transcripts that are pretty amazing. And they have this diarization. I don't know if that's what they call it, but they have Jared, Adam, whomever else labeled. Why is it possible there? And why is it such a hard thing here?
Yeah, I think the explanation is basically Whisper wasn't designed for this task, and I guess most likely they're using something that was designed for this task. Some other models, it was trained to do the diarization, and yeah, you can always like plug in some third-party project and algorithm network to do this extra step. It would be cool to be able to do it with a single model, but
Right.
For now, it's not possible.
Is it kind of like converting your wave files to 16-bit first before using the model? It's like that. It's like one more step in the mix, basically.
Yeah, but it's even worse than that because it's like a much harder step. It's basically like running it through Whisper and then running it through a separate thing, which its entire purpose is segmentation or diarization. And then it's like two passes. Whereas what we're talking about, it's like, well, FFmpeg dash whatever. And it's like, this is just like the tooling around that it puts us, see, for me, there are solutions that seem like they're kind of hacky and people are getting them to work, but it's like back in the Python world again. And it's very slow because of that, from what I can tell.
So against Python, Jared.
I don't hate Python. It's just like
this pip install has got you really upset. We've got to solve this.
No, it's just, I like the simplicity and the straightforward stuff that Georgi does. I just want it in whisper.cpp.
I know.
I think like maybe Whisper 2 will just support this feature and then we'll all be happy, right? Like you'll just upgrade your models and everything. You'll just check it off your roadmap. But if not for something like that, I think it is probably a difficult thing to accomplish just because the models aren't set up to do that particular task. Like they're just set up for speech recognition, not for, I don't know, speaker classification or whatever you call it.
Yeah, with the way things are going lately, I suppose like by the end of the month, OpenAI will probably release a new model which supports everything.
The day we ship this episode, it'll support that.
This stuff's moving at the speed of light right now, so
yes,
it probably will be. By the time this ships, it'll probably be a feature of Whisper 2.
Yeah, I think so.
Hopefully. So the project, I should give it a shout out. I do not dislike Python. Pyanote, Pyanote is what people are combining with Whisper in order to get both features through a pipeline. So if you're interested in that, people are doing it. It seems a little bit buggy. They aren't quite happy with the results, but they have some results.
You gotta be careful because Brett can't listen to the show, Jared, and sometimes he even reads transcripts. You might just like scan for his name or Python, essentially. He's got two searches on our transcripts.
Well, now you just brought his name into it. He wouldn't have been able to find it until just now.
I've been thinking too behind the scenes that, the fact that this runs on Apple Silicon, when you got the ARM thing that's kind of baked in there, I believe it is called Neon, which I think is pretty interesting. This Neon technology kind of in that separate sort of super processor or additional processor speed. Like, what did you learn or have to learn about, Apple's silicon to make this project work? What did you even, not so much learn to make it work well, but what did you learn about the processor that was like, wow, they're doing that in this consumer grade, pretty much ubiquitous or available to mostly anybody who can afford it, obviously. What did you learn about their processor?
Yeah, so ARM Neon, this is the name of the instruction set that runs on the Apple Silicon CPUs. And when I started GGML, I recently had like my shiny new M1. I have been using it for my workstation, like transitioning from Linux.
Oh, wow. You're a Linux convert. Okay.
Yeah, but this machine is so good, I decided to switch, and
You won't go back?
I think I'm not going back anytime soon.
Elaborate. I'm listening. Go ahead.
So yeah, I was interested in understanding how to utilize, and basically this is called like single instruction multiple data SIND programming, where you utilize this instruction set to process things faster. And I wanted to get some experience into that, so I had this implemented in GGML to like support for the heavy operations to use ARM Neon. And what it requires to be able to use it, just read the documentation and figure out how to properly load and store the data in an effective manner. It's a tricky stuff in general. I'm no expert by far, so like I'll probably mention this at some point. But like people are looking at the code lately, and they're like helping me optimize these parts. They're kind of difficult to code in general. So yeah, our Neon is helping for the CPU processing, and then there is this extra Apple framework, which I'm not really sure which part of the hardware it utilizes. Basically, this is the Apple Accelerate framework. It has a linear algebra API, so you can say, okay, multiply these matrices, and somehow it's really fast. And I think it's running on something that is called like AMX coprocessor, but it's not super clear to me. I don't really care. It's just fast, so so why not use it?
Right.
This is one of the optimizations. Yeah.
What I found interesting when I was, kind of researching a little further to kind of prepare for this call was that this is a quote unquote secret coprocessor. It's called the Apple Matrix coprocessor. AMX is what they call it. And it's not very well known. And so as this, Apple Silicon is only a couple of years old, it's not that old. So, even examining or building new software technology on top of it. But like this is, I think we have to look at, one of the many reasons that Apple chose to abandon Intel and go their own routes. And obviously a lot of the work they did in their mobile devices, from an iPhone to an iPad, and all the things happening in their processors led them to this direction. But like even this, the accelerated coprocessor that is there secretively, essentially just waiting to be tapped into, is kind of interesting because it does what it does,
Yeah, I guess when you make your own hardware and software, you definitely get some advantages compared to not doing it. So I think it's a good approach. I like this way.
We're even speculating too on like Apple and artificial intelligence, and maybe this is the glimpse into their genius that is not yet revealed. Because if you can do what you've done with this coprocessor and this Neon ARM technology and this AMX, this Apple Matrix coprocessor, we have to wonder, what are the reasons why they went this route? It couldn't be just simply to put it into our hands, but to put it into our hands for them to use in some way, shape, or form. So it's got to make you wonder what the future for them might be in AI, because they are really black box and secretive in terms of new features and new products and things like that. But this might give us a glimpse into that future.
Yeah, true. I don't know. I'm not really competent. As far as I know, like the optimal way of Apple is to use CoreML, like some other framework which utilizes like everything, like neural engine, GPU, CPU, whatever. Yeah, and I think they, for example, recently demonstrated how to run stable diffusion with CoreML, quite efficient. So yeah, I guess like using Accelerate, it's not really something new. It's probably not even the right way to go in the long run, but for now it
works.
It's okay.
It works for now. It's good enough for us regular people. So on the Whisper front, I know we should get to LLaMA here soon because it's the most exciting new thing, and here we are burying the lead. deep into the show like fools. But Whisper is interesting to me. The GPU support. So one of the things about it is it's simple. It's great hardware support, right? Very generic. Runs on the CPU. You do have GPU support also on the roadmap. Is that something that you put it on there because people ask for it? Or are you actually interested in this? Because it seems like it could definitely complicate things.
Yeah, GPU support I avoid because you usually have to learn some framework like CUDA, OpenCL, stuff like this. It's complicated. It takes time to understand everything. There are like some workarounds like using, what was it called, MV Blast, where it kind of automatically does it for you. But I don't know, there will be some probably in the future, some basic support. I think more interesting is the, for Apple hardware, is the transition of the encoder part, like one of the heavy parts, to the Apple Neural Engine, which we already have a prototype.
Oh, nice.
And this will kind of speed up the processing even further. So that's.
Have you been able to run any benchmarks against your prototype, or have you got into that phase where you're actually seeing how much gains you're getting?
Yeah, this was a super cool contribution. Basically, I read about CoreML. I decided I'm probably not going to invest time in learning all this complex stuff. But suddenly one day, while a contributor like posted, you can see the linked issues in the repo, how to do it, which was super great. And he demonstrated it's possible. We initially observed like 3 times speed up, I think.
Nice.
But then other people joined. They showed us even how to make it even better. And I like this because like people are contributing, like sharing ideas, making it faster. And so I guess at least 3 times. But this is just the encoder. Like the decoder remains not optimal. So it's not super great overall.
You gotta love that moment with an open source project where you start to get significant contributions, right? Not drive-by README fixes or docs, which are helpful, but not like this is a significant contribution of a new way of doing something or proof of concept. And that's pretty exciting. It seems like your 2 projects now, especially Whisper, because it's been around a lot longer, has had a lot of very smart, coder types, not afraid of hopping in and really helping out. Did you do anything to kind of cultivate that, or is it just the nature of the project that it brings a certain kind of contributor?
Yeah, I'm also wondering about this and really enjoy it. So my previous projects, like they didn't have a lot of contributions involved, and now with Whisper and LLaMA, I really like that it's getting attention. Did I do anything specific? Not really. I guess just people find it. Maybe first of all, they find it useful and they start suggesting ideas for making it even more useful. And then people eventually start joining to make code improvements and stuff like this. And there is, I think, I don't know, from my perspective, it's a relatively big momentum currently. People are very interested in supporting this. Yeah, I try to make it so they're kind of able to get into it, like create some entry-level tasks and things that people can get involved, because eventually, like currently, there are so many requests and issues and all this stuff that's kind of very difficult to handle by my own. So it would be nice to have more people involved.
All right. Switching gears now. I think we put the cart before the llama, Adam. I don't know if that rings true to you.
I was actually wondering if we should have our good friend Luda bring us in. LLaMA, Repajama. You know what I'm saying?
Ludicrous. Oh, yeah.
LLaMA, Repajama. Ludacris is here.
Yeah,
Fate
man.
of the Furious in theater tomorrow.
Hey, LLaMA,
Repajama.
reads a story with who? With his mama.
Hey.
Mama kisses, what? Baby hair.
I've been dying to do Red Pajama, llama drama. There's all these rhymes, and
Sure.
haven't been able to work those in quite yet. But
I knew you were.
getting to it now, the most exciting thing on the interwebs, until I guess GPT-4 stole some steam yesterday, but February 24th, Facebook Research, or Meta AI, who knows what they call themselves these days, released LLaMA, a foundational 65 billion parameter large language model. And then, according to some commentary, a European alpha coder went on a bender one night and ported it to C++ so we can all run it on our Pixel phones. So that's the story, Georgi.
How do you feel about being called a European alpha bender?
European alpha coder. I thought that was a funny way of casting it by somebody on Twitter.
Yeah, I really like this meme. It originated on Twitter, like someone calling me a alpha male European or something. I don't know. It's kind of funny.
Well, you did. So you did hack this together in an evening. Is that lore or is that true?
Yeah, it's basically kind of true. But again, it's a combination of factors and good timing and some luck. Basically, we had the 4-bit quantization stuff for the Whisper, just an idea working, like where you take the model, you compress it down to 4 bits. You lose some accuracy, but it's smaller and processes faster. So we had that like in DGML, and it was available. So a few days later comes out the LLaMA. I do some calculations and I figure 65 billion parameters. You probably need about 40 gigs of RAM with 4-bit quantization. So this can run on a MacBook. Why not do it? And yeah, it just was a matter of time to find some free time to try it. And yeah, last Friday, came after work home, had the weights downloaded. But why I was able to do it so quickly? Basically, it's from what I saw, is pretty much GPT-J architecture with some modification, like some extra normalization layers. And some minor changes. Basically, again, the existing code for the GPT-J, I just simply modified it, and it happened pretty quickly.
Yeah, you had a leg up. Prior art helped you that you created.
Yes, yeah.
So that quote, success is when, what is it, Adam?
Preparation meets opportunity. Yeah.
Right. So like Georgi was perfectly prepared between this GGML library that he'd previously developed and this knowledge he has. Like he was like primed for this position.
For sure.
Yeah.
Which is great. I love that when that happens in my life. And so I applaud that moment for you. Cause I mean,
yeah, man,
when you're in the trenches and you feel like you're like in the wilderness and you put some code out there and you know, in the case of Whisper.cpp, you got a glimpse of, you know, your hacker direction, your hacker sense, you know, that you feel, well, use a spidey sense kind of play on words. And, you know, you've done it again. Why not, you know, port another popular, you know, direction for artificial intelligence in everyday life? Boom. Done. That's my hype way, Jared. Boom, done.
I like that. Boom, done.
Boom, done.
Right off into the sunset.
Yeah.
So why do you think people are so excited about this one in particular? So I guess, you know, Whisper is very much for audio. It's more scoped to a smaller domain, whereas LLaMA is like your typical text autocomplete thing. Like it's going to do, like, create your own ChatGPT is basically sort of not the pitch, but it's more akin to that. And ChatGPT is so interesting and sticky for people that this is just like, okay, now we can go build our own little text AIs. Is that what you think is why it's like if you check the GitHub stars on this thing, like the chart, it's pretty much straight vertical. Like it just goes straight up the y-axis. There is no x-axis. I'm exaggerating a little bit for dramatic effect, but you know what I mean? People are really, really running this thing.
Yeah, I'm also wondering. I don't have a good answer. I guess it's the ChatGPT hype.
Yeah.
Doing inference locally, having your like chat assistant on your device and stuff like this. I don't know. I personally just try to kind of keep it real. Like, as I told you, I was a non-believer like a few months ago.
Right.
Now it's hard to ignore, like,
It is.
It seems to be working. It does work.
You actually seem less excited about this than like anybody else who's been posting onto Mastodon and Twitter. I'm running it on my Pixel phone, 1 token per second, you know, obviously slow. I've got it running on my MacBook. It's over here on this Raspberry Pi 4 now. I mean, people are having kind of been invigorated by it, but
yeah,
what I'm getting from you, Georgi, is like, it's cool, but it's not like maybe Whisper is even cooler.
Yeah, I find Whisper much more useful. Like it solves a very well-defined problem, and he solves it really good.
Yeah.
So with the text generation, I mean, OKA is developing quite fast. I don't have I personally haven't seen anyway. Let's not go in this direction, but
Okay.
yeah, I think people are just basically excited to be able to run this locally. I'm mostly doing it for fun, I would say, and
Did you have to agree to those strict terms to get access to the model from Facebook?
I submitted the form, but
Okay. Did you read the terms?
Did you get the memo?
yeah, of course I read them.
Okay.
That's for sure.
Why did you read them, Adam?
I haven't read them. I'm paraphrasing from Simon Willison's article on the subject when he says you have to agree to some strict terms to access the model. So I just assumed that, you were cool with the strict terms. I'm in quotes here. You can't see me on video. The strict terms.
Yeah, I'm not distributing it. So
Right.
So I'm not
Okay.
distributing the word. So I think that's totally fine.
Is that kind of how like you agree to an end user license agreement, Or you just you scroll to the bottom and hit the checkbox? Not you, Gorky, but like the royal you, like everybody.
Yeah, of course. You just hit agree.
Yeah, exactly. I actually had a friend who had a great idea for that back in the day where you could provide EULA acceptance as a service, and you just go and you live somewhere where no EULAs apply or something, like out there in the middle of the ocean, and you then outsource the checking of the checkbox. People could just have you check it for them.
Yeah.
And so they both get the checkbox checked, but then they have plausible deniability because they didn't actually check it. And then one person just checks it for all of us, but that person's outside of any jurisdiction. And so we win. What do you think, Adam?
I love it. I'm going to subscribe to that. Please, Jared, put that link in the show notes so I can follow it and utilize that link.
How cool would that be?
That would be cool.
So now you have these two projects. One is kind of taking off, at least at the moment, more than the other one. Maybe it's merely on the hype wave. Maybe there's more to it than that. Obviously, there'll be more models released soon that also need to be ported over for us. Where do you go from here? Where do you take it? Are you dedicated to doing more for Whisper? Do you think LLaMA is where you're going to put your time? Do you not care about any of these things? You're just having fun? Because I know this is just like fun for you, right? This is not your job.
Yeah, I'm doing this basically in the free time. And I don't know, for the moment, I just plan to try to make it a bit more accessible, maybe attract some people to start contributing and help out because there are quite a lot of requests already popping up. And my personal interests are just try to do some other fun, cool demos and tools and examples and stuff like this. I don't know. I kind of, from one point of view, I don't really want to spend like super much time into these projects and prefer to get them hopefully into state where other people are helping out so I can do other stuff. And
so in terms of extensibility, you said by way of allowing others to come into the project, contribute code, help you move it along. I assume part of that is desires for other integrations with like popular C++ libraries or frameworks. Our good friend, ChatGPT-4, as a matter of fact, that's the model I'm using to get this request. Something like OpenCV, or I believe it's called Egan, and potential other advantages for integrations. Are you thinking about stuff like that where other C++ applications or libraries can leverage this work to sort of take it to the next level or do other things with it? To give an example, OpenCV is a real-time optimized computer vision library. It offers different tools, and Egan, I believe, is something similar where it's more around linear algebra, matrices, vectors, numerical solvers, etc., related to algorithms. Have you thought about that kind of other angle where it's not so much just you, but leverage of this in C++ land?
okay, so yeah, my point of view for these projects, I prefer things to be super minimal and without any third-party dependencies, and like I just prefer it like this way. Keep things simple and don't rely on other stuff. If you ask the other way around, could other projects use GGML?
That's my angle, is can they use you?
I'm thinking about it, and I guess like GGML is kind of like, I would say it's a beginner level framework. Like there are really more advanced and mature frameworks for this type of processing, for sure. Like, and even probably more efficient. I guess there is hype around GGML because it's kind of simple and you can tweak stuff easily and these things. But if you want to make something like a quality product, let's say, or something like more production, you probably should use some existing and well-established framework, let's say. But still, I think I'm surprised. I'm super surprised by the interest of GGML. Can it become something more? I don't know. Maybe we'll give it a try in some way and see if we can evolve it. It will be, I don't know, I don't have a good vision because I'm doing it to be useful to me. The good thing is I see people are kind of understanding it already, which I kind of did not really expect because see stuff and there's like some weird things. But maybe, who knows, with time it can become something bigger. I'll be happy to see that happening.
I'm curious about your path and how maybe it could be emulated. So, what if other people would love to be a European alpha male coder like yourself, Georgi? How did you learn this stuff? I know obviously you've been doing this in your day job, C and C+, or things that C++ are programming language you've been using, but can you share some of your path either to maybe programming in general, but specifically like getting into this world of being able to build these tools that work with these models? How'd you learn this stuff?
Yeah, okay. So I've been basically programming since pretty much high school, and I have a lot of interest in coding. I do it as a hobby in my free time. You can see like my GitHub is full of random geeky projects and stuff. So I basically pretty much enjoy it. My education background is physics. I studied physics in university, have a master's in medical physics. But yeah, after university, I started working in the software industry. And I don't know what is the path. And I feel a bit weird, already hearing to answer this type of questions. But
Okay.
I just enjoyed. I find it fun.
Sure.
And yeah, I guess that's it.
Yeah. I was hoping part of your path might be the potential desire to continue to play and provide potential future ports, as Jared kind of alluded to earlier, which was, this kind of reminds me, Jared, of like whenever APIs were early and thriving and you had the whole mashup phase where you can like take one thing and do another, or you can,
right.
I think even when with his work early on to get into GitHub was work on, I believe at the time was Octopress. No, it wasn't Octopress. It was something OctoKit.
OctoKit?
I think it was renamed to OctoKit though.
Okay.
It had a different name for a while there. I think potentially written in Ruby. It was essentially, an API SDK essentially, I think of it like this. Like this is kind of like that era where you have these models coming out, you need ports and you need this, and this is like a potential, new fertile ground for one, not so much newcomers because you've been programming for quite a while, but new into this scene where you're providing, high quality ports that people are using that have a lot of stars on GitHub and a lot of popularity. Preparation meets opportunity, obviously, and great timing. So I just think that's kind of like maybe an interesting space we're in right now with this, newfound stuff happening.
Yeah, I mean, I think that's totally be your call, Georgi, because you're doing this because it interests you and because you get, I don't know, intellectual stimulation from it. And if it gets boring, like just porting the next big model that gets released because people expect you to or something, I could see where that would no longer be worth it for you.
Right.
Do you have bigger ambitions with this? Do you have an end goal in mind? Or are you just kind of opportunistically following your interests and your hobby and coding up cool stuff and like a couple things happen to be smash hits?
Like bigger opportunities, as you can imagine, like my inbox is full of of people asking me to do stuff. I wasn't really planning on doing anything. There is one idea which we'll probably get try. We'll see, and it's in the same path as I mentioned, like trying to get people involved and contribute and try to grow this approach. And I don't know, I don't have like any big expectations from this. For example, I'm not gonna like promise anything. I have a lot of ideas for random cool hacks. This is what's interesting, and I'll probably eventually implement those and share them, and I hope people like them.
Yeah.
One thing that Simon said, I'm going to paraphrase one thing he said in his coverage recently of LLaMA, and he also mentions Georgi, so good to mention this. He says that furious typing sound you can hear is thousands of hackers around the world starting to dig in and figure out what life is like when you can run a GP3 class model on your own hardware. And I think that this conversation and what you've produced is a glimpse into, that phrase that sentence or two he shared. Because I think that's kind of what happens. Like, you can now run this on your own hardware, an M1 Mac or an M2 Mac if you've got an Apple Silicon, and get results pretty quickly. Better than the 20 hours you had, Jared, initially with the non-C++ version of it, which I think is pretty interesting. So, I just love this. It's kind of like this new invigoration in the world where it's like, wow, I can run these, high-class models on my own machine and get results and play, which I think is the most truly fun part about software development, hacking, programming, whatever you want to call it, is this ability to play to some degree with your own rules in your own time on your own machine and not have to leverage an API or buffering or anything like that whatsoever with an API where you have no rate limits. You just got your own thing to do and you can play with it. You can integrate FFmpeg to do different things, to preface it to a 16-bit wave. You can maybe, before Whisper 2 comes out and you want to do diarization, transcripting, you could do that too. You don't have to wait for the thing to happen. And obviously, if Whisper 2 supports that feature, roll back your code and not use it because it's baked into the model now. But that's the cool thing I think that's happening right now. Would you guys agree?
Yeah, I guess you don't even need heavy hardware, which is expensive or hard to run and maintain and all this stuff. So it opens up interesting opportunities for sure.
Well, even the GPU aspect, like you can build your own machine. You can buy a phenomenal NVIDIA or AMD GPU. You could build your own CPU up from the motherboard to the compute to the RAM to the GPU. But system on a chip is like readily available to pretty much every human being, given the money affordance in your own pocketbook to pay for it, of course. But system on a chip, this Apple Silicon is pretty interesting how it just bakes all that into one thing and it's integrated. You don't have to build your own machine to get there, is the point.
Yeah, Apple Silicon for me is quite exciting. I expect it to become even more approachable and usable, or what was the word? So yeah, I think it's a bit still a great idea to run this. The efficiency is not quite there yet, but with the way things are progressing, like exponential growth of computational power and exponential shrinkage of the models, many in 1 year, maybe 1 year you'll be able to do on your CPU what you're currently able to do with modern GPUs. I guess. I don't know.
Well, Georgi, thanks so much for coming on the show, man. This has been fascinating. I love that you're just kind of the true hacker spirit of just coding up this stuff in your free time because it's something you love to do. And your path to get here is just I just code on this stuff all the time because it's what I like to do. Your work is helping a lot of people. It's definitely also riding the AI hype cycle that we're currently on. So hopefully it continues to go that way. I think that we'll lose people as we go, but as things get better as well, we'll put this stuff in the hands of more and more people on their own hardware, with their own software, easily integrating. And especially from us, we're not quite yet using Whisper because we're still trying to figure out that speaker identification bit. Thank you so much for guaranteeing it in the next 6 months. I'm just joking, but we're excited about it, and we can see a future where this directly benefits us, which is super cool. And in the meantime, it's benefiting a bunch of people. So yeah, I just really appreciate you taking the time. I know you don't do podcasts, so this is your first one, and prying you away from your keyboard from a night. I mean, think about what you could have done with this time. You could have changed the world already.
That's right.
But instead, you just decided to talk to us. So we appreciate that.
Yeah, thanks for having me. I enjoyed it.
Well, something you may not know, because we almost never tell you, but we have a YouTube channel. Mainly we use it for clips and features from shows like this, of course, The Changelog, JS Party, Go Time, Founders Talk, Brain Science, the entire Changelog podcast universe clips. They're all there at youtube.com/changelog. You should subscribe. And if we're giving you that much value to go to YouTube and subscribe, you might as well check out Changelog Plus. That is our membership. Yes, we love our members. We drop the ads. We bring you a little closer to the metal. We give you bonus content. We give you discounts at the merch store. So cool. And on the note of bonus content, we have a bonus segment today for our Plus subscribers. So if you're a Plus member, check it out. It's right after this. If not, changelog.com/plus. It's too easy. Once again, a big thank you to our friends and our partners at Fastly and Fly, and also our good friends over at TypeSense, blazing fast in-memory search. So cool. Typesense.org. Check it out. And those beats are banging. Breakmaster Cylinder brings it every single week for us, and we appreciate it. Of course, thank you also to you, our listeners. Thank you so much for choosing to listen to this show all the way to the very end like this. We appreciate you. But that's it. This show's done. We will see you on Monday.